Hey guys, what's happening? So in my last video I showed you the Cereritas and my road to 200k 2000 millimeters per second. But this is actually my first attempt at a high-speed printer. I called this the Orcinus, which is Orca in Latin. And you can see there's little Orca killer whale logos everywhere on the thing everywhere. Actually, I never uploaded any of these printers to Thingiverse, just because I was doing other things, busy IT work and working. So, yeah, like with this printer too, I've designed everything from the ground up, from scratch, not copied anything from anybody. But this is actually a Core XY design. I probably designed this maybe a year and a half ago, 2 years ago. I started on it. But this was, like I said, was also designed as a high-performance, high-speed printer. So I'll go through the unique features of this printer. Yeah, it's running a Clipper. I just updated a Clipper on it. So it's running. I just got upgraded to Clipper 13. I still got to flash the MCU, but I was waiting to turn it over to show you guys. But some of the unique things about this printer was the quad bed leveling, quad belt bed leveling, and the ball socket design. So I don't know if you guys can see that in there. See the ball socket? Well, the bed tilts in all different directions like that. So I can get this thing extremely dialed in. Flat. It's running a glass bed. But here's another close look at the ball socket design. Quad motors. I'm running a MKS Monster 8, but I'll show you that. Spool back here. So on the motors up here, I'm running LDO Speedy Power HTs. Which can run about 2.5 amp, I think, max. But originally I had this plastic back here, but then because I wanted to step this up to the next level, I machined these aluminum heat sinks. So besides it, pulling this massive heat sink, it's also going to be distributing the heat down this aluminum rail down here. So that will hopefully be absorbing more heat. But I mean, this is a thick piece of aluminum, and you can see the motor in it. Like that. So, yeah, this is a direct drive. And I'm running the HGX Lite extruder with the Nemo 14 round motor. And originally I had like one of those the CAN bus tool boards up here, but things are unreliable, man. So I went back to just straight wires. So much easier to troubleshoot that way. CAN bus can be a nightmare to troubleshoot, because everything's going over one communications line. It's harder to troubleshoot the individual sensors. So if you get like a thermistor error or some kind of error, you don't know if it's a CAN bus issue or if it's a thermistor issue. It's easier to troubleshoot when they're individually wired. So here's a closer look at it. Back here, we got a camera on it. I guess I was running Raspberry Pi 4 7-inch touchscreen. Let me flip it over, because I got to upgrade the firmware on it. So let me flip it over and I'll show you what it looks like underneath. Alright, so here's the bottom right here. So I think the power, I can't remember, this is a while since I've actually been underneath this printer, so at least probably about a year. So I think it was like a 30 amp power supply, 24 volt, 30 or 40, but I actually upgraded the fan on this thing. So I'm running an MKS Monster 8 board, and then I also have the two BigTreeTech external 5160 drivers here. You can see that in there. So yeah, it has the external MOSFET. So you have the driver, then you have the external MOSFET, so you can send a lot more current. Plus the capacitors are a lot bigger. They're a bigger buffer. And that is the heated bed. So I'm running 24 volt heated bed. Obviously, AC heated bed would be better. So everything's being shared off one power supply. And it actually worked as I mean, this was like my main big format printer until I got the big one over there. The big Trudon 400 by 400 massive printer. But it's like I said, originally when I designed this thing, I designed it for like super high performance, but then I never experimented with it too much, just because it was my only large format printer I had at the time, so I didn't really want to break it. So I did all the upgrades, designed it for high performance, and just never really, I mean, I pushed it maybe 200 millimeters per second, but nothing crazy. Just because I was mainly just printing with all the time. I was printing out my other printers. So this, I think this printer printed out the Cereritas. Yeah, like once I designed the Cereritas printer, then I just kind of stopped playing with this one. But yeah, I want to go do them side by side and see what I can max this thing out at. So the Cereritas at 24 volts maxed out yesterday at 125K. Was like kind of failing. 125K, 1,250 millimeters per second. So I gotta upgrade the firmware. Like when I designed this, for some reason I didn't think that like I redesigned the other cooling duct on the Cereritas so I could get to the SD card better. So I might redesign the fans just so I can get to this thing easier. So I just basically have to take off a couple screws and get to the thing for the SD card so I can do the MCU firmware. And here's a closer look at the legs too. So the legs were I had them super robust legs. And when this printer was, well, when I was thinking when this printer would move and flex, these wheels or the legs have ball pivots, so it would pivot and move with the printer. Alright, let me do a quick hum. Like I said, I haven't maybe a long time since I've messed with this printer. Yeah, I don't know. I guess last time I printed on this was probably 4 or 5 months ago. Let's do yourself home. And I'll show you the before I start doing test prints. I'll just show you. I'll show you the quad bed leveling. Well, if you're wondering, I actually fix 3D printers for business and personal. Not so much I mean, I do some few personal printers in my off time, but I do fix 3D printers for business. So if you look down below, there's a link in this video. It's called oc3dtech.com. So I kind of got into that during COVID. I mean, it doesn't pay as good as IT work, so I don't know. It's like IT work pays a lot better. All right, so I do actually have a micro probe. I have one of those. If you probably can't even see it, but there's a little micro probe in there. And then, like I said, the cooler, to tell you that, but the cooling fan is a little blower fan back here. It works pretty good. I mean, I printed probably 500 things on this printer, probably. Alright, so yeah, this was my first Core XY printer. My first Core XY printer was, I built it from scratch. I didn't actually buy one. I mean, the belt routing is very similar to a Voron. But it's different. So, like I said, this whole belt system is slightly different than a Voron. And you have the belt tensioners, which I should probably check the belts. The belt tensioners are here in the front. You just tighten them up in the front. Alright, let's do the quad gantry level. So I use the Voron quad gantry level, but I modified it for my stuff. So it's just going to go through. And it's the same thing as sort of like a Voron, but instead of actually moving the whole gantry, I'm just moving the bed on the ball pivots with the individual belt motors. So it just kind of goes from corner to corner. Yeah, you really can't even see the micro probe. I have it hidden back in there, so in there. But there you go, that's the micro probe. Alright, we'll come back and we'll do some speed tests. You know, if you saw my video yesterday, I actually, on the Cereritas, I actually copied the design from this printer. That I designed this little belt latch tensioning system. See with the pulley, you just tighten here, tighten this 2mm screw here, M3, and then basically it just brings up this pulley here. That's how I tension the belts. Oh yeah, it's riding on, it's all linear rails. So it's running on quad, the bed is quad linear rails. So yeah, this was not, I mean, I don't know, this wasn't a cheap printer to build, I guess. Yeah, it's all linear rails. Those black linear rails. Alright, so it's been a couple days, and I actually put my test boxes on here. So I have 50K, 800 millimeters, all the way up to 150K, 1500 millimeters. Like, this is not going to beat the Celeritas. I mean, I highly doubt it. I mean, it does have good motors, though. I mean, they do on 60s externals and heat sinks and LDO motors. So, alright, let's try the 50K 800 millimeters. Alright, it's gonna, I'm just doing heating up. Okay, 60 degrees bed temp. So I'll come back right before it goes to high speed. My guess is it's gonna fail somewhere in this belt latch if it does fail, because it has failed here before. But it typically will pull out of there when I actually have the belt tension too tight. So, and actually I think I redesigned it. I can't remember. Like I said, I haven't messed with this for a while, so I think I had redesigned it. Actually, I should probably lift up the rails too. He's putting down the first layer. Obviously, I'm not putting anything out right now because I already know the volcano hot end's not gonna hang. I mean, you need an extruder with a really long melt zone, which I'm designing right now. I was actually designing a couple different designs. I just got to build them. One with nichrome wire on it. Some with the, I don't know if I have some with the volcano hot end on there on the top of the mill. Get a closer look at the belt system right there. And those heat sinks I built. Yeah, I mean, I guess I could always put fans on those too if I had to. Yeah, any second now. So much quieter than the Cereritas. Yeah, definitely more. Definitely more quiet though. Yeah, I need to actually have this thing on some more stable footing. Maybe even on the ground, maybe, you know? Yeah, but it doesn't help actually that it's fighting with the... That's doing pretty good. Like I said, 50K, 800 millimeters per second, so... Like I said, I designed this for high performance. It wasn't like it was, you know... yeah, this whole thing that's on there now is kind of rocking back and forth. But it has those nice legs on it. Yeah, it's like not even... Any leg off? Let me adjust these legs maybe a little bit. There's on something. There we go, that probably helps. This is definitely the fastest I've ever had this printer room, I think. Okay. Cool. Alright, I'm going to let this actually fully run to see how warm these motors get. And then we'll step it up. We'll step it up until it fails. Yeah, it definitely feels I definitely need a more stable platform. Alright, so as this thing was moving, I mean, I could see like some of these things had become loose, so I tightened those down. So, motors, I mean, barely even warm. I mean, these are gigantic heat sinks, but they're barely even warm, so it's a good sign. So we're going to step it up to 75K 800 millimeters, so the same, but we're just bringing it up 25K. Yeah, there's just, I mean, there's no way this thing's gonna go as fast as the Cereritas. Just because I can feel the weight of this big, heavy-duty piece of aluminum up here. You know, the linear rail, the steel linear rail, all this weight up here. You can just feel it in the frame, you know, as it's moving around. All right, so I think I had mentioned these at some point. These were Super Power HTs. But they're actually Speedy Power HTs. Because originally I had ordered the Super Power HTs and they sent me the wrong motors. They were wrong in the back. So they actually ended up sending me some new motors, the Super Power HTs. But so HT is basically high temperature. So that's Speedy. I can't remember the inductance of the motor, but it was pretty low. You know, low inductance, so it should go pretty fast. All right, let's go back. I just did a quad gantry level. Print and 75K. Alright, we should be good to go in a second. I think I missed it. I have to hold the printer. I'm worried about coming off the thing. Alright, so it couldn't even hang it, kind of recovered. My current run current is 2.2 amp. So I'm going to bring that up to 2.5 amp, which is the max of the stepper. There's always like a diminishing return of current though. Yeah, I think obviously stepping up the voltage would be the way to go, but I'll have to get a separate power supply for that. I might have a 40 volter. I guess because I'm only driving 2 drivers, I'm not driving the whole system. You can kind of probably get away with a smaller power supply. Alright, let me step up the current. I'm pretty much sure we're going to be locked up around 800 millimeters per second, 75K. It's just too heavy. You almost need like quad motors, you know? Alright, like so this is going to be 75K, 800 millimeters, and 2.5 amp, which is actually the max on the speed. Well, that's what they say. Speedy Power HT. Yeah, Speedy Power HT. I forgot to mention, this is not the ideal situation because I'm running the heated bed off the main power supply. So everything's sharing one power supply, every single motor. So it's not ideal. It'd be ideal having a separate power supply just for the actual motors, which I'm going to do. So, same with this printer too. Yeah. Once it locks up on that first thing. Definitely moving now. Yeah, but I should be over here, not towards the... Yeah, I'm gonna crash this thing. Yeah, just in that first move, I have to hold the printer down, it shakes so much, so heavy. I mean, it's definitely moving. I mean, it's even at 75K, 800 millimeters, definitely moving. I know the motors feel. Yeah, the motors aren't warm yet. Like I said, it's hard to know. You have the heatsink. Heatsink's getting a little bit warm. Motors are getting a little bit warm. But yeah, when you step up the voltage, they get really hot, really warm. All right, yeah, that's a big move. All right, cancel it. I'm actually surprised the belt didn't actually pop out. I guess because I think when it happened the last time I reprinted the center part, made some fixes, improvements, but alright, so the Orcinus is stuck at 75K 800 millimeter. Alright, let me know what you guys think down below, but yeah, I'm thinking I'm going to be doing 48 volts or 60 volts probably. I know the drivers themselves can handle 60 volts. I'm probably going to get a power supply that can go anywhere from like 48 volts to 60 volts with like adjustable potentiometer. Alright, cool. I always kind of wonder what this thing could do. I'll say it's nothing compared to the Cereritas. Just too much weight up here. I mean, this thing is just so much lighter. 4-drive motors. This thing is just so much heavier. You can just feel it, you know what I mean, as it's moving around. So much weight going on up here. Alright, cool. I was kind of wondering about that. Alright, let me know down below. Awesome.